Hi, this is Steve and welcome to Uncharted DIY. Today's project is a compost tumbler. I know you've seen a lot of compost tumblers online, but the engineering and design of this one is quite a bit different. When this barrel is full of compost, it could weigh up to 400 pounds. And with the engineering on this A-frame, it makes it a lot stronger than the T-posts that you typically find online. Another huge advantage is that you can tuck the wheelbarrow underneath and tip the compost down and pour it out this way into the wheelbarrow without making a huge mess. So let's get started on building one of these. To make the legs for the frame, start by measuring out the legs and cutting them according to the free plans you'll find on UnchartedDIY.com. If your barrel is within an inch or two of 38 inches tall and 23 inches in diameter like mine, the measurements on the plans will work just fine, and it eliminates calculating the angles for the leg bottoms. If your barrel is taller or shorter than my barrel, you can adjust the length of the legs longer or shorter as needed. However, if you change the lengths from the plans, the angle of the leg bottoms will change as well. Just make sure it's going to sit flat on all four legs when it's done. If your barrel is larger or smaller diameter, the axle spacers and temporary supports may vary from mine, but make sure the 36-inch pipe used for the axle still fits your design. I'm using redwood 2x4s to withstand the weather we can get in Colorado, but pressure-treated or plain pine will also work. The top corners of the leg tops are cut off at a 45-degree angle to remove pointy edges and to make it more comfortable to handle, but this is optional. After the four legs are cut, we'll need to drill a 1 1/4 inch hole in each leg, centered from the top and sides of the leg tops. This is where the axle shaft will go through. I'm using the spade bit and scrap wood to support the legs while drilling. This prevents the bit from making my work surface into a giant slab of Swiss cheese. And it also keeps the wood from tearing out as the bit penetrates the back of the hole being drilled. Okay, once you're done with the legs, the next step is we want to attach these in such a way that they're going to sit flat on the ground. So what I've done is I've taken my straightest piece of wood here. I'm going to use it as my reference point for flatness. And because this one is going to be raised, I have it up on blocks and adjust as needed. I'm using 2.5 inch deckmate screws because these are definitely for outdoor use and they're really strong. And there's one side done. We'll do the exact same thing again for the other side. There we go. The next step is to measure for where we're going to put the cross braces. The measurement for the first leg is going to be 5 5/8. And then on the inside, we're going to use the exact same measurement. Connect those two together. And we'll do the same thing on the inside of this leg. These two marks are the lower of the cross braces. Now we're going to mark for the upper cross brace. These will be 7 1/8. All right, now with them marked for the cross brace, when these are put together like this, I calculated the dimensions and the angles for the A-frame base on the computer. Unfortunately, in the real world, wood is hardly ever perfectly straight without warps, bows, and twists. So I came up with a way to use the actual assembled legs to measure and cut the braces instead of plans based on theoretical straight lines. If you're a mathematical savant, it might be easy to calculate the rate of torsion along the length of a 2x4. For the rest of us, this simple mechanical method will minimize the potential for brain damage. For this process, you'll need a precise 90-degree right angle tool. A speed square or a framing square will work great for this. A straight edge. You'll also need a sharp pencil and a flat work surface you don't mind making pencil marks on. Here, I'm just using a couple of sawhorses with a particle board sheet laid on top as my work surface. Here's how the braces will be placed when they're finished. The first step is to make temporary supports to hold the legs in place while the measuring is done and for attaching the braces to the legs. These can be made of old cut-off pieces of pine, 2x4, or whatever you have laying around. Once the supports are attached by using screws or clamps, we can figure out the angles and lengths for cutting the braces, taking into account that the 2x4s for the legs may not be perfectly straight. The way to do that is to butt that straight edge right up to the inside edge of the leg, and then draw a line on your work surface. This line represents the actual angle of the leg. Then with a square on that line and the upper part overlapping the inside of the leg, line it up with the mark we made for the lower brace, right where the line meets the square on the inside of the leg. Make a perpendicular cross mark at the bottom of the square. Repeat this for the leg diagonally across. Then remove the frame. Now lay the 2x4 that will be the first brace on the marks we drew, making sure the board meets the cross marks as shown, with the left side cross mark on the bottom of the board and the right side cross mark on the top. Then you can look down on the 2x4 from directly overhead and mark the board using the long lines on the work surface for reference. These marks are where we'll cut the board. Once cut, line the boards up with the legs so the upper inside corners meet the legs as shown. Then repeat this process for measuring and cutting the upper brace that runs diagonally the other way. Getting the proper dimensions this way may sound complicated, but it's actually much faster and easier than it sounds. And there's no complex math involved. Okay, now with this cut, we can line it up. And what I've done here is just placed a couple blocks, some cut-offs, 2x4 standing upright and then one across. This lines up with the lines that I marked out. Then I'm going to line them up like that. And just so they don't move around when I go to attach these, I'm going to use some clamps. So I'm sure you've heard the saying, you can never be too rich. Well, you can never have too many clamps. What I'm using here are 2 7/8 inch structural wood screws. These are super strong to really help hold this together. So what I'm going to do is take a look and see here where the deepest part of the wood would be, which is more toward the back. And that's where I'm going to screw this through so that it doesn't come out the front. That is super solid. Next one goes on exactly like the first one. And again, I'm not trying to clamp these. I just want to keep it from doing this while I'm putting the structural screws in. Now I'm using an impact driver to put these in with. As you can see, it saves a great deal of time. You could put these in with a socket wrench, but it would take forever and you'd have to pre-drill holes. This makes quick work of anything. If you don't have one of these, you need one. And I'm going to add these 2 1/4 inch deckmate screws. Then I can remove the temporary supports. Then I can remove my upper temporary clamp. Now I could just leave these overlapping pieces out here like they are, but I don't want to end up gouging my shin running into one of these. So instead I'm going to cut these off. That's completely optional. To cut these off with, I'm going to use an oscillating multi-tool. It'll make quick work of this. And with that, the base is complete. The first step in this process is to measure the height of the barrel. To do that, I just used a piece of scrap 2x4 that I had laying around, but you could use a broom handle or anything else that will project out from the top so you can measure down to the base. So now that I have the measurement on my barrel, I want to measure out where I'm going to put the hole, and I know that I need to put it right in the center. So on mine being 38 inches, that's 19 inches. And so again, if you use the wood trick and just put something flat up against there, then I can measure without having to just eyeball it. That's perfect. Now with this mark made, what I'm going to do is take the end of my string and line it up with this mark like that. And just to make sure that this doesn't get pulled this direction or this direction, you put another piece of tape along the side of it and the other one. Then I'm going to take my string and go all the way around, make sure to keep it level, and make a mark. There, by going around the opposite way, just make sure that I haven't done anything to miscalculate. So this mark is still correct. Now I can take the string, put this mark right back up, and then pull this tight. Where this meets is my halfway point. So what I can do then is turn my barrel. I'll take this around, look for my mark. That is my halfway point. And again, to verify, I'll go around, make sure it lines up. That is perfect. And that is the exact opposite hole. Next, I'm going to use a 1 1/4 inch hole saw, mount it in the drill, and we'll drill the first hole. The molding line of the barrel is in the center, so I already know that I can use this to line up where I'm going to put the flange by looking at it this way, but I don't know in this dimension where to make this cut. So I'm going to measure that and trace around it. That's going to be my hole. I happen to have the perfect size hole saw for this, but you could just as easily drill a hole in here and then use a jigsaw to cut it out with. Now while I have this upside down, I want to drill the drain hole. Had I thought about it, I probably should have put the axle in line with this mold line. Would have made things a little bit easier, but that's okay. What I'm going to do instead is put the axle through the hole so that I can see where it intersects the barrel. And at about 90 degrees, I'm going to drill a drain hole. So for the drain hole, I'm going to use a 1 inch hole saw to cut that with. Now we're going to drill the vent holes in the top. These will be right above this axle line. But I'm just going to use this to make sure that they're even. And I want to make them even horizontally. So I'm just going to eyeball that right there and right there. Right there and right there. And I'm going to use the 1 inch bit again and drill these out. That completes all the holes for the barrel. I used a bandsaw to cut my threaded couplings in half, but you could do this with a hand saw. The hose washers with the screens go inside the half coupling and get pushed down in there. This way it's an easy to remove screen. All you need to do is reach inside the barrel, unscrew this, and replace this screen. This will allow air in and keep bugs out. Now we need to install the vents. So these adapters get screwed in, and hand tight is plenty tight. Then the threaded coupler with the screen in it gets screwed on from the inside. Before I drill the air holes in the ABS, I need to test fit this into the barrel so I can make sure I know exactly where the axle is going to go through this pipe. So I'm not going to glue this on all the way yet. I'm just going to get it pretty tight on there. Make sure that it's good and flush to the bottom like that. Now, the next step is going to be determining exactly where the axle is going to penetrate that pipe. So to do that, I'm just going to take a Sharpie and some paper towel here, wrap the paper towel around the Sharpie, and then I'm going to put that in the actual pipe just like that. So the Sharpie is right in the center of the pipe. Now making sure this is perfectly horizontal, I make a mark. And once that mark is made, I need to pull this pipe back out of the barrel. So now I can see on my pipe here exactly where the shaft is going to penetrate. So I'm just going to pick, by placing a vertical mark here, where my first hole is going to be drilled. And then I'm going to use the string trick again. Go around to the back and make my other mark. And now I'm going to drill a 1 1/4 inch hole through this pipe. Okay, that looks great. Perfectly across from each other. Now, before I go ahead and drill out all the air holes, I'm going to test fit this one more time. So we'll take this back out. And now I'm going to drill all the air holes that go in this. I'm laying out a grid on mine so I know where to drill the holes. It doesn't really matter if the holes are evenly spaced and precise, but this just helps guide me to make sure I get enough of them in there. I'm using a 1/2-inch spade bit. So the way I'm laying out these holes is I take one line and I drill one hole on every cross piece. And I'm going to go directly across from that and do the next one. Then I'm going to go 90 degrees, so halfway in between these. I have holes every 90 degrees along here. If I start putting more holes in between these, I'm afraid I may end up weakening the pipe. So what I'm going to do is just go in between these on the next line. So I'm staggering them. So I'm just going to clean this off so I don't end up with PVC shavings in the compost. The final step in preparing this air hole pipe is to glue the pieces on. This is permanent, so this is why I test fit everything ahead of time. That piece is finished. The final step in preparing the barrel is to add the drain. So this is just going to get screwed in, and then inside I'm going to put 1/2 of one of these threaded connectors. That's just to act as a nut on the other side, and I'm going to make it aim out so this can drain downward. So this is a solid cap plug, and that's what I'm going to cap this with to keep this from draining out until I'm ready. This is a great way to drain off some of the fluids that collect in here, and you can make compost tea out of them. Next, we're going to put in the center air hole shaft, and we'll be ready to mount it to the frame. Okay, so we're going to line up. We're going to eyeball this main axle hole with this main axle hole. Because this piece that I took out is so thick, I don't feel the need to put bolts through here with nuts on the other side. I think simply screwing into this, there's plenty of meat there that it's going to provide plenty of grip. So I'm just going to use number 8 construction screws. These happen to be 1.25 inches. And they go in great. Based on that, I think 8 is enough. And if you're of the same age as I am, that should remind you of a cheesy TV show. That is plenty solid. Now with this done, we're ready to put it on the frame, make our spacers, tighten the whole thing up, and then we're finished. Okay, with this on here, we just need to measure the distance between the wooden frame and the barrel. And we're going to make PVC spacers that fit in those gaps. I'm going to take this 1.5-inch PVC pipe and cut off 2 2 3/8 pieces. For the ends of this, I want to add a bit of a spacer so that when I screw the cap on, it tightens everything up and makes the top of this frame really sturdy. So I'm just going to take my 1-inch PVC coupler here and cut it down to that measurement. On a lot of these videos, people are putting screens inside this flange before they glued it, but I want mine to be replaceable. This whole design is based on being able to replace all the screens. So I'm going to just lay down a piece of screen and then put the screws through that. I know I joked earlier about 8 being enough, but because I'm putting the screen on here, I'm going to go ahead and add 2 more. Just make sure there's no way for bugs to get through here. This is Steve, and thanks for watching Uncharted DIY. My next project is going to be a follow-up on this one. It's going to be a motorized shaker table or compost sieve that automatically sorts the compost into 3 different sizes. If you found this video helpful, please like and subscribe and leave questions and comments below. And also check out UnchartedDIY.com, where you'll find further information and more detailed how-to projects.